Section 2.4, rational expressions. Okay, whenever you hear the word rational, you should think fraction, okay? Anytime you hear the word rational, think fraction. So 6/9, think about how we would simplify 6/9. Okay, we talked about it before, but you could simplify 6 as 2 times 3, and you could simplify 9 as 3 times 3. So in a way, I could look at 6/9 and think about that as 2 times 3 over 3 times 3. Okay, and then of course, 3 over 3, those would divide and give me 1, or 1 over 1. 2 times 1 is 2, 3 times 1 is 3. That simplifies to 2/3. Okay, so we're going to use that same strategy to simplify something like this. Alright, so this right here is a rational expression, x minus 2 times x plus 8 over x minus 6 times x minus 2. So you'll notice that x minus 2 over x minus 2, those two divide out. They become 1s. So that becomes 1 times x plus 8, which is x plus 8. And that becomes x minus 6 times 1, which is x minus 6. So you'll notice this simplifies to x plus 8 over x minus 6. Okay, of course they're not always going to be nice like that, right? Most of the time they're going to need to be factored in order to simplify it. So that's what we're going to focus on now. So let's take some time. 3x squared minus x minus 4. 3x squared minus x minus 4. I'm going to simplify that, or I'm going to factor that, I should say. And I'm also going to factor 3x squared plus 11x minus 20. Alright, so in order to factor, let's do this rather quickly, right? We're going to use the AC method because we have something other than 1 in front of that x squared. We're going to start off by multiplying 3 times negative 4. That will give me a negative 12. So I need two numbers that multiply together to be negative 12, but when I add those numbers together, they add up to the middle negative 1 here. Okay, and so I think through my numbers real quick, and I come up with negative 4 and positive 3. Negative 4 times positive 3 is negative 12. Negative 4 plus 3 is negative 1. So I can use the negative 4 and the positive 3 to split this into 4 terms. Okay, once it's split into 4 terms, I'm going to group together the first 2 terms, group together the last 2 terms, factor out my greatest common factor. So the common factor between 3x squared and negative 4x would be x. If I divide out that x, I'm left with 3x minus 4. 3x and negative 4, the only common factor they have is a 1, so I'm going to factor out a positive 1 here. If I divide 3x minus 4 by 1, I'm left with 3x minus 4 still. So this first part factors as 3x minus 4 times x plus 1. That's going to be the top of my fraction. I know I went through that pretty quickly. Remember, if you need more help with factoring, go back over the factoring section. Okay, so go back a little bit and review it. Now I'm going to factor 3x squared plus 11x minus 20. So I'm going to start off by multiplying 3 times negative 20. 3 times negative 20 is going to be negative 60. Do this down here. I need two numbers that multiply together to be negative 60 but add together to be 11. So that's going to be what? Negative 15, no, negative 4 and 15. Negative 4 times 15 is negative 60. They add together to be 11. Okay, so I'm going to use that to split 3x squared minus 4x plus 15x minus 20. Group together my first 2 and last 2 terms, and then we're going to factor out the common factor. 3x squared minus 4x, my common factor is x. That leaves me with 3x minus 4. 15x minus 20, I'm going to factor out a 5. That leaves me with 3x minus 4. So overall I have 3x minus 4 times x plus 5. That's my denominator, 3x minus 4 times x plus 5. Okay, once you factor the numerator and the denominator, it's usually pretty easy to see. 3x minus 4 over 3x minus 4 will cancel out, leaving me with x plus 1 over x plus 5. Okay, let's do another one. This one looks worse, but it actually is not. So we have x cubed plus 2x squared minus 63x over x squared plus 10x plus 9. Okay, remember, you should always check to see if there's a common factor before you factor it the rest of the way. In this case, all three of these have a common factor x, so I will factor that out first. X comes out, I'm left with x squared plus 2x minus 63. Now, I don't have a number besides a 1 in front of that x squared, so I am going to see what two numbers multiply together to be negative 63. I'll bring that down some. But add together to be 2. Okay, if I find those two numbers, I can jump straight to my final answer. Remember, that's allowed whenever there's a 1 in front of the x squared. Okay, so numbers that multiply together to be negative 63 but add up to 2 would be negative 7 and positive 9. They multiply together to be negative 63. They add together to be 2. So my numerator will factor to be x times x minus 7 times x plus 9. Okay, the entire numerator is now written as factors. Now for the denominator, x squared plus 10x plus 9. Okay, I need two numbers that multiply together to be 9 but add together to be 10. Okay, that one's not too hard. 9 and 1, right? 9 times 1 is 9. 9 plus 1 is 10. So this will factor to be x plus 9, x plus 1. Okay, great. So now the top is factored, the bottom is factored. X plus 9 divided by x plus 9 will divide out. They cancel each other out. Again, remember, that's leaving you with 1's here. So it's x times x minus 7 times 1 over x plus 1, right? 1 times x plus 1. So there we go. X times x minus 7 over x plus 1. Okay, so we see the strategy, right? We just simplify. Now let's get to some slightly more complicated problems. So before we do that, let's do this easier problem here. 6/5 times 10 over 21. So we're going to multiply two fractions together. I think you probably see where this is going to go, but let's start with this. Okay, 6 over 5 times 10 over 21. Real quick, remember that you multiply the top numbers together and you multiply the bottom numbers together. That's always true when you're multiplying fractions. But let's go ahead and find the prime factorization for 10. That's 2 times 5. And 21. That's 3 times 7. Okay, so instead of writing this, oh, while we're at it, let's find the prime factorization of 6 as well. That's 2 and 3. Okay, I did this because now I can rewrite this as 2 times 3, that's 6, times 2 times 5, that's the 10, over 5, that was a prime number, so I couldn't break that down, times 21, which is 3 times 7. So I wrote the numerator and the denominator in terms of factors. It's all multiplied out. Okay, so then that means I can go and divide things out. 3 divided by 3, those will cancel. Gives me some 1's. 5 and 5 also gives me 1. So if I look at the numerator now, that's 2 times 1 times 2 times 1. That comes out to be 4. The denominator is 1 times 1 times 7. That comes out to be 7. Okay, so we reduce the fraction. Again, keep in mind the resulting fraction, right, the product. Keep in mind what we're doing here, the strategy. Write it in terms of its factors so that things will divide out. That's the goal. So here's an ugly problem. Let's work through it, okay? So we know that we're going to write this as one fraction. If I can draw a straight line, that'd be nice, but I guess it's not that important. Let's factor these one at a time and see what cancels out, okay? Matter of fact, I'm going to do that here. I'm going to go ahead and say x squared minus 9x minus 10. Okay, I need two numbers that multiply together to be negative 10 but add together to be negative 9. Okay, well that would be negative 10 and positive 1. So this would factor as x minus 10, x plus 1. Again, I'm going through this quick. Go back to the factoring section if you want to see it more broken down. Remember, keep in mind if it's an understood 1 in front of the x squared, you can skip all those middle steps for the AC method and go straight to the end. Okay, that's what we're going to do for all 4 of these. Okay, let's do the next one. Or let's do the denominator here. X squared plus 13x plus 36. I need 2 numbers that multiply together to be 36, but add together to be 13. Okay, so I'm thinking through some numbers there. 9 and 4 would do that. 9 times 4 is 36. They add up to 13. So x plus 9, x plus 4. Okay, let's go on to x squared plus 7x plus 12. I need 2 numbers that multiply together to be 12, but add together to be 7. Okay, that would be 3 and 4. 3 times 4 is 12. 3 plus 4 is 7. So this will factor as x plus 3 times x plus 4. And then x squared plus 10x plus 9. 2 numbers that multiply together to be 9, but add together to be 10. That one looks familiar. It's 1 and 9. So x plus 1, x plus 9. Okay, so I did all of that. Let me rewrite this this problem here, this expression. So we have x minus 10, x plus 1, right? That's the first top left. Then we have on the bottom x plus 9, x plus 4. Okay, x squared plus 7x plus 12. Okay, we'll have x plus 3, x plus 4. And then finally, bottom right, x plus 1, x plus 9. Okay, now let's see what cancels out. Remember, for them to divide out, you have to have something on top and bottom that match, right? So in other words, this x plus 1 over x plus 1, those will divide out. This x plus 4 over x plus 4 will divide out. These x plus 9s do not divide out, right, because they're both on the bottom, so they're not going to cancel. Okay, so I'll write my final answer at the bottom here. Probably not the most efficient way to write this out, but it'll work. X minus 10 is left. X plus 3 is left. X plus 9. And x plus 9. Okay, you may also write this one like this if you prefer. X minus 10, x plus 3, over x plus 9 squared. Okay, you could also write it like that if you want. It's a little bit more efficient. Okay, there's one more type of problem we need to talk about. So we multiplied them. Of course, the next thing is division, right? So let's talk about division real quick with regular fractions before we deal with some variables, right? So 2/5 divided by 6/5. Remember, to divide a fraction, you change it to multiplication. That's really 2/5 times 5/6. That's when you take that second number, you flip it over, and multiply it. Okay, and so now when I multiply this, okay, we have 2 and 5 over 5 times, okay, well 6 is 2 times 3. Okay, kind of going through that quick, but the 2's would divide out. The 5's would divide out. So I'm left with 1 times 1 on top, 1 times 1 times 3 on the bottom, 1/3. Okay, the strategy, flip the second, change it to multiplication, and then treat it like a multiplication problem. So guess what? Here we go. We're going to flip this over and then treat it like a multiplication problem. So x squared plus x minus 12 over x squared minus 9x plus 18 times x squared minus x minus 30 over x squared minus x minus 6. Okay, so now factor the top for top, bottom, right? Factor all 4 of them. I can't count, apparently. X squared plus x minus 12. 2 numbers that multiply together to be negative 12, but add together to be 1. I understood 1 in the middle there. Would be 4, negative 3. So this will factor as x plus 4, x minus 3. x squared minus 9x plus 18. I need two numbers that multiply together to be positive 18 but add to be negative 9. That would be negative 6 and negative 3. So this factors as x minus 6, x minus 3. X squared minus x minus 6. I need two numbers that multiply together to be negative 6 but add together to be negative 1. That would be negative 3 and 2. So this is going to be x minus 3, x plus 2. And x squared minus x minus 30. I need two numbers that multiply together to be negative 30 but add together to be negative 1, negative 6 and 5. So x minus 6, x plus 5. Now I have to keep in mind that I flipped the second fraction, so when I write it out I need to be careful of that. So x squared plus x minus 12 is x plus 4, x minus 3. The denominator, x squared minus 9x plus 18 is x minus 6, x minus 3. Okay, my new numerator is this x squared minus x minus 30. That's x minus 6, x plus 5. And then my new denominator is this x squared minus x minus 6. That's x minus 3, x plus 2. Okay, so let's see what we can cancel out. X minus 3, x minus 6, and that's it. So our final simplified fraction here is x plus 4, x plus 5 over x minus 3, x plus 2. Okay, I think that was the last one. So there we go. We multiplied and divided and simplified rational expressions.